There is this really famous quote from the Ernest Hemingway novel, The Sun Also Rises.
Oh, yeah, I know the one you're talking about.
Right, it's so good. So a character is asked, how did you go bankrupt? And his answer is just, well, it's perfect. He says two ways, gradually, then suddenly.
It really is the perfect framework. I mean, the most profound technological shifts always seem to follow that exact pattern.
They totally do. And I've been thinking about this quote nonstop because, it perfectly describes our relationship right now with artificial
Oh,
intelligence.
absolutely.
Because for decades, we were basically living in the gradually phase. AI was this incredibly abstract, highly academic thing.
Right, happening in like university labs or massive corporate server rooms.
Exactly. It was the stuff of science fiction or, really obscure academic papers. And then,
Then this suddenly hits.
yes,
Wow.
late 2022 and early 2023. It felt like someone literally flicked a switch and AI just exploded into every single facet of our lives.
Business, social feeds, everywhere.
You literally could not walk past a newsstand without seeing it. I mean, Time Magazine, Science, Cosmopolitan, The Economist.
They all threw out their planned covers.
Right. They dedicated entire issues to AI.
It was a true global awakening, honestly. It wasn't just tech enthusiasts talking about it anymore.
Oh, not at all.
I mean, you had King Charles in the UK publicly calling it one of the greatest technological leaps in human history.
Oh, yeah.
And the UN Secretary General calling the pace of development unprecedented. Even the Pope stepped in.
Wait, the Pope? Really?
He dedicated the World Peace Day message of 2023 entirely to the use of AI.
That is wild.
He pointed out its potential to, positively contribute to the future of humanity, as long as it's guided ethically. So,
Yeah.
yeah, when the Pope is talking about algorithms, you definitely know the sudden phase has arrived.
Okay, yes, that is the ultimate proof. Which brings us to the core mission of our deep dive today.
Oh.
We are speaking directly to you, the listener, specifically you, the business leader, the operator, the strategist in the travel and tourism sector.
Because it's noisy out there right now.
It is deafening. When a technology shifts from gradual to sudden, the sheer volume of noise is just, well, it's overwhelming. You're getting bombarded with pitches for AI software.
Constantly.
You're reading terrifying headlines about job losses and hearing promises of, like, trillion-dollar productivity gains.
It is incredibly hard to separate the marketing hype from the actual physical mechanics of how this stuff works.
Exactly. And more importantly, exactly why it matters to your hotel, your airline, your tour company, or, your destination marketing board.
So to cut through all that noise, we're going to be unpacking a really fantastic, highly foundational resource today.
Yes, we are.
We're drawing from an extensive, really detailed report published in January 2024. It was produced by the World Travel and Tourism Council, the WTTC, in partnership with Microsoft.
It's an incredibly comprehensive guide. And it opens with a foreword by Julia Simpson, the president and CEO of the WTTC.
A really strong forward, too.
Yeah, she makes a point that I think really sets the stakes for this whole conversation. She says that for business leaders in travel, understanding both the opportunities and the very real challenges of this technology, it isn't just optional anymore.
No, not at all.
It's not some shiny object you can just ignore. It is absolutely vital to your survival and growth.
Her message is very grounded, I think. This isn't about, like, worshiping the technology. It's about recognizing a fundamental shift in how business is done. It's about how AI can help the global tourism sector grow, how it can create hyper-personalized experiences.
Which guests are demanding now.
Exactly. And how it can drive sustainability and just generally help you navigate what is becoming an incredibly complex future landscape.
So we have a pretty serious journey ahead of us today, but we are not just going to read you a table of contents or throw a bunch of tech jargon at you.
Please no.
Right. We need to actually open the hood of the car and look at the engine. We need to figure out why this matters to you.
And to really understand where this technology is going and why 2023 felt like such an earthquake, we have to understand how we got here.
The history part?
Right. We have to look at the gradual. Because the reality is, AI didn't just appear out of nowhere. Technically speaking, this field has been slowly, painstakingly building for nearly a century.
Which is wild to think about. I mean, I think a lot of people assume AI was invented in Silicon Valley like maybe 10 years ago.
Right, by some kid in a hoodie.
Exactly.
Right.
So where does the true story actually begin? Who laid the first brick?
If we trace the intellectual origins of this whole conversation, we really land in 1950.
Okay, 1950.
With the celebrated British mathematician and codebreaker, Alan Turing. By this point, Turing was already a legend.
Oh, sure, the Enigma machines.
Exactly. He had famously helped decode the German Enigma machines during the Second World War by essentially building one of the world's very first electromechanical computers.
An absolute genius.
Wow. Completely.
Hmm.
But in 1950, he published a groundbreaking, purely theoretical paper titled Computing Machinery and Intelligence.
Okay.
And in that paper, he posed what is still, honestly, the ultimate question of this entire field. He asked, can machines think?
But he didn't just pose it as a philosophical riddle, right? Like, he was a scientist. He proposed a way to actually measure it.
Exactly. He introduced the imitation game, which the world now universally calls the Turing test.
The ring test, right?
He realized that defining thought or consciousness was just too slippery.
Mm.
Like, how do you measure that? So he made it practical. The premise is this. You put a human judge in a room and have them communicate via text with two entities hidden in another room.
Okay, one human, one machine.
You got it. One is a human, the other is a computer. If the computer can answer questions and hold a conversation so convincingly that the judge cannot reliably tell which is the machine and which is the human,
Then it passes.
right. Turing argued that, for all practical purposes, we must consider the machine to be intelligent.
It's brilliant because it bypasses the biology completely. It just says, look at the output. If it acts smart, it's smart. But the phrase artificial intelligence wasn't actually Turing's, was it?
No, that came a little bit later.
Yeah.
The specific term was coined in 1956 at what is now a pretty legendary event called the Dartmouth Conference.
In New Hampshire.
Yep. This is a summer research project organized by a computer scientist named John McCarthy. He basically gathered a small group of brilliant minds from mathematics, engineering, cognitive science.
Kind of like the Avengers of early computing.
Literally. And they spent weeks exploring this radical concept of thinking machines. They officially named the field artificial intelligence.
Wow.
That conference is widely considered the Big Bang of AI as a distinct academic discipline.
Okay, so that's the start of the gradual phase. And for decades after that, it was kind of a slog, right?
Oh, a massive slog.
We had these massive mainframes that took up entire rooms just to do like basic algebra. It was highly theoretical. But then as we get closer to the turn of the century, the timeline really starts to accelerate.
Yes, the machine started to do things that actually grabbed the public's attention. We started seeing machines not just processing data, but competing against human masters.
And winning.
And winning. The most famous early example was in 1997. IBM had built a massive supercomputer called Deep Blue.
The chess computer.
Exactly. Its sole purpose was to play chess. And it played against the reigning world chess grandmaster, Garry Kasparov.
And it beat him.
Deep Blue won. It was a huge deal.
I remember seeing the footage of that. Kasparov looked physically shaken, like he could not believe a machine outsmarted him. And then IBM did it again over a decade later, right? In 2011.
Yes, with a different system called Watson. IBM Watson went on the U.S. television game show Jeopardy!
Oh, man, Jeopardy is a whole different beast.
It really is. It competed against the two greatest human champions in the show's history, Ken Jennings and Brad Rutter. And Jeopardy! Is much harder for a computer than chess.
Right, because chess is just math and strict rules.
Yes, exactly. Jeopardy!
Yep.
Involves natural language, puns, wordplay, and just really obscure trivia. But Watson absolutely crushed the human champions.
Okay, but hold on. I look at Deep Blue and I look at Watson. And as impressive as they were, they feel very different from what we have today.
How so?
Well, they were highly specialized, incredibly expensive supercomputers that required an entire team of engineers just to turn them on. And more importantly, they were doing purely analytical tasks.
That's a very good point.
Right, like chess is a closed system. Trivia is just fast database retrieval. It's impressive calculation, sure, but it doesn't feel like thinking the way you and I experience it.
And you were hitting on the exact catalyst for the sudden explosion. You're completely right. For decades, the public basically viewed AI as a giant calculator.
A really fast calculator, but yeah.
It was doing analytical feats. But the turning point, the moment the world gasped, was when the technology shifted from analytical calculation to creative generation. It started doing things we assumed were exclusively the human domain.
Right. And this brings us to the art world, because there's a huge moment in the sources about this. The year is 2018. A portrait titled Edmond de Bellamy goes up for auction at Christie's in New York.
Christie's, which is huge.
Yeah, this is an institution that sells Picassos and Monets. The portrait sells for a staggering $432,500.
Almost $500,000.
$500,000. But no human hand ever touched a brush to make it. It was generated by an AI algorithm that had just been fed thousands of historical portraits until it, learned how to make its own.
That 2018 sale was a massive wake-up call for the art world. But the WTTC report highlights just how terrifyingly fast the technology evolved after that.
Yeah, the speed is
If
nuts.
you actually look at that Edmund de Bellamy portrait from 2018, it's pretty blurry.
It looks kind of smudged.
Yeah, a bit abstract. You can tell a machine made it. But fast forward just 5 years to 2023, then the AI isn't just making blurry portraits anymore. It is matching the great masters.
The museum examples in the sources are completely surreal. So there's the Mauritshuis Museum in The Hague, in the Netherlands. Okay.
They own Johannes Vermeer's legendary painting, Girl with a Pearl Earring. They loaned the original out for an exhibition somewhere else. And while it was gone, they decided to temporarily replace it in their gallery with a piece of AI-generated art called Girl with Glowing Earrings.
Just put it right on the wall.
Right on the wall.
Yeah.
And tourists walked in, looked at it, and many just assumed it was a real physical painting hanging there.
It's incredible. And it wasn't just visual art either. The music industry experienced the exact same seismic shift. In 2023, the Recording Academy, which runs the Grammys,
The Grammys.
yes, they officially announced that music containing elements created by artificial intelligence would be eligible for awards.
That honestly blows my mind.
The applications were wildly diverse, too. On one hand, you had Paul McCartney announcing that he used AI to meticulously extract John Lennon's voice from a really crackly, low-quality old demo cassette tape.
Oh, wow.
Yeah, the AI isolated the vocal frequency perfectly, allowing them to mix and release the final Beatles song now and then.
So that's a beautiful use of it. But
Mhm.
on the other extreme, right, on the other extreme, you had the Canadian pop singer Grimes doing something totally radical. She openly invited her fans and producers to create new songs using an AI-generated clone of her voice.
She just gave her voice away.
Basically,
Huh.
she essentially open-sourced her own vocal identity. She offered to split the royalties 50-50 with anyone who made a commercial hit using her digital clone.
That is wild. Artists literally crowdsourcing their own digital ghosts.
And this is exactly why 2023 was the sudden. It was the democratization of the technology.
He wasn't locked away anymore.
Exactly. It was no longer a multi-million-dollar supercomputer locked in an IBM laboratory playing chess. It was cheap, highly intuitive software available via a web browser to anyone with an internet connection.
Yeah.
Suddenly, any person on Earth could generate art, photographs, and music from their couch.
So when I try to wrap my head around this massive shift, the best analogy I can come up with is electricity.
Electricity, okay.
Yeah, because when electricity was first harnessed, people didn't just invent one thing. Electricity isn't a single tool like a hammer or a wrench. It is what economists call a general-purpose technology.
Right. It fundamentally changes whatever you plug it into.
Exactly. You plug it into a glass bulb, you get light. You plug it into a metal box, you get a refrigerator. You plug it into a set of wheels, you get a train.
That's a great way to look at it.
And AI feels the exact same way. It changes whatever it touches, whether that's healthcare, diagnosing tumors, artists generating music, or, for our listeners, travel companies completely overhauling how they book, price, and market trips.
Absolutely.
But here is my biggest hangup. If AI is the electricity, what exactly are the wires and the power plants making it work?
You want to look under the hood.
I do, because I feel like we talk about the AI like it's a wizard behind a curtain. How do we actually open up the hood of this thing and understand the physical mechanics?
That is exactly where we need to go next. Because
Yeah.
to understand how you can utilize this in the travel business, you have to demystify the black box.
Please.
The WTTC report breaks this down incredibly well. The sudden leap in capabilities that we just talked about, the deep fakes, the music, the chatbots, it isn't magic.
It's mad.
It's the result of the massive convergence of three very specific physical elements: algorithms, data, and compute.
Okay, I want to take those one by one and really interrogate them. Let's start with element number one, algorithms.
The brains.
Right, we can call these the brains of the operation. But I need you to explain this to me plainly. How is an AI algorithm fundamentally different from the standard computer programs and software we've been running on our laptops for the last 40 years? What actually changed?
It requires a complete shift in how we think about programming. Let's look at traditional programming first. For decades, writing software meant writing a set of explicit, rigid instructions.
Okay.
You, the human programmer, encode your knowledge into rules that the computer follows step by step. It is essentially an endless series of if-then-else decision trees.
Give me an example of that, just to ground it.
Sure. Let's say you want to build a medical diagnostic program. A human doctor sits down with a programmer and says, if the patient has a temperature over 101 degrees, and if they have a cough, then prescribe drug X.
Got it.
The programmer writes that exact logic into code. The computer has no intelligence of its own. It is blindly following a recipe predetermined by a human. If you give the computer the rules and the data, it outputs the answers.
Okay, so a traditional program is just a really fast, really obedient rule follower.
Exactly.
If it encounters a situation that the programmer didn't explicitly write a rule for, it just crashes or gives an error. So how is an AI algorithm different?
AI flips that entire equation upside down. AI systems are not explicitly coded with precise steps to solve a problem.
They aren't.
No. Instead, they're designed to learn how to solve the problem by examining data. In AI, you don't give the computer the rules. You give the computer massive amounts of data and the answers, and the computer mathematically figures out what the rules must be.
Wait, back up. It figures out the rules. I'm sorry, I'm not buying that. How does a machine figure anything out without a human telling it how?
I know, it sounds crazy. It does it through probability and statistics, primarily through two major fields highlighted in the report, machine learning and deep learning.
Oh, okay. Let's break those down.
Machine learning, or ML, is the broader category. It refers to algorithms that can learn from huge amounts of data, identify patterns, and make decisions with minimal human intervention.
Okay.
And, crucially, they improve their accuracy over time as they are exposed to more and more data.
So a travel company using machine learning might, feed it 10 years of historical flight pricing data and weather patterns, and the machine learns the pattern of when prices spike, allowing it to forecast future prices.
Exactly. You didn't tell it the rules of pricing, it found the rules in the data. But machine learning has its limits.
Like what?
If the data gets too messy or the problem gets too complex, like trying to understand human speech or generate a photorealistic image, traditional machine learning struggles. And that is where deep learning comes in. Deep learning is a highly sophisticated subset of machine learning, and it is the true engine of the modern AI revolution.
So how does deep learning work differently?
Deep learning uses complex mathematical architectures inspired by the biological structure of the human brain. We call these artificial neural networks.
Okay, let's pause right there. Neural network is one of those buzzwords that gets thrown around constantly at conferences. What does it actually mean physically in the code? It's not a real brain.
No, it's not a biological brain in a jar. Think of it as layers of mathematical filters. You have an input layer where the data enters. You have an output layer where the final answer comes out.
Okay.
And in between, you have multiple hidden layers of artificial neurons or nodes. That's why it's called deep learning. It has many, many layers of depth.
I see. So what do these layers actually do?
When data passes through these layers, each node assigns a mathematical weight to the information. It's essentially deciding how important is this piece of data to the final answer. As the network processes millions of examples, it constantly adjusts those weights, fine-tuning its own internal math until it consistently produces the correct output.
It sounds incredibly complex to build. Who actually figured out how to do this?
The foundational architecture of deep learning was pioneered over decades of obscure, often underfunded research. The WTTC report specifically highlights three computer scientists, Yann LeCun, Geoffrey Hinton, and Yoshua Bengio.
The heavy hitters.
The media often refers to them as the godfathers of AI.
Godfathers of AI. That's a heavy title.
It's deserved, honestly. They're pioneering research in the 1990s and early 2000s on how these multi-layered neural networks could learn through a process called backpropagation. That laid the foundation for everything we have today.
Wow.
Their work was so profoundly important that in 2018, they were jointly awarded the Turing Award.
Named after Alan Turing. We've literally come full circle.
Exactly. The Turing Award is considered the highest possible honor in computer science. It is essentially the Nobel Prize of computing. They won it for their conceptual and engineering breakthroughs that made deep neural networks a reality.
Okay, so these godfathers of AI build these neural networks, but I'm still stuck on the learning part.
Okay, what part?
If I have a human child, I teach them by pointing at a dog and saying, "Dog." I give them a textbook. How do you actually train a neural network? What is the actual teaching method?
There are three primary methods that these algorithms use to train, and understanding the difference is really crucial for a business leader trying to figure out what software to buy.
Let's go through them.
The first and most common historically is called supervised learning. This is exactly like your example of teaching a child. You train the AI using a data set that has been explicitly and correctly labeled by a human.
Let's ground this in the travel industry. Give me a supervised learning example for, a hotel.
Sure. Let's say a global hotel chain. wants an AI to automatically scan user-uploaded photos on travel review sites to flag images of dirty rooms.
Okay, great use case.
To train the AI using supervised learning, humans must first manually gather thousands of photos.
Hmm.
A human must look at each photo and tag it. This is a clean room. This is a dirty room. This is a clean room.
Okay.
You feed that labeled data set into the neural network. The AI looks at the pixels of a photo, makes a guess, and then checks the human's answer key. If it guesses wrong, it adjusts its internal weights. It repeats this millions of times until it can identify a dirty room with 99% accuracy.
Okay, I definitely see the value, but that sounds agonizingly slow. You
Yep.
have to pay armies of humans to sit in cubicles clicking and tagging thousands of photos before the machine even starts to learn. Is
Really?
there a faster way?
That is the major bottleneck of supervised learning, and it brings us to the second method, unsupervised learning.
I'm supervised. Okay.
Here, the training data is entirely unlabeled. You don't give the AI an answer key. You just hand the AI a massive, chaotic pile of raw data and essentially say, find the hidden patterns.
Wait, how does it know what it's looking at if no one tags it? If you hand it a million travel photos, how does it know what a beach is if you don't define it?
It doesn't know the human word beach, but it doesn't need to. The neural network analyzes the raw mathematical properties of the data pixel colors, edges, shapes, frequencies.
Oh, I see.
It notices that a huge subset of photos all feature a horizontal line separating a large blue area on top from a textured tan area on the bottom. It mathematically clusters those photos together.
So it groups them by similarity without knowing what the objects actually are. How is that useful for our travel and tourism listeners?
It is incredibly powerful for discovering things human analysts might miss. Imagine an airline feeding a decade of raw, unlabeled customer purchase histories, web browsing logs, and customer service call transcripts into an unsupervised learning model.
That's a lot of data.
Huge amounts.
Yeah.
The AI might find a hidden cluster. It might say, hey, there's a massive mathematical correlation here. Customers who search for flights to Japan in November are highly likely to also click on culinary tour links and generally spend 30% more on upgraded seats.
Wow.
Humans never thought to look for that specific pattern. Unsupervised learning reveals the unknown unknowns.
That is massive for marketing. Okay,
Yeah.
so we have supervised learning with the answer key, unsupervised learning, finding hidden clusters. What is the third method?
Reinforcement learning. This is learning by trial and error. There is no labeled data and there's no raw clustering. Instead, you put the AI system into an environment, which could be a simulation or a game, and you give it a goal.
A goal, like win the game.
Exactly. The AI takes an action, and the environment provides a continuous feedback loop of mathematical rewards or punishments.
So it's literally like training a dog with treats and scoldings.
Exactly like that. If the AI takes an action that moves it closer to the goal, it gets a +1 reward.
Yeah.
If it moves away, it gets a -1 punishment. It learns purely by doing, constantly adjusting its strategy to maximize the reward over thousands of iterations.
Give me a real-world travel application for reinforcement learning.
Think about a global logistics company or a major airline trying to optimize their daily flight routes. You set the goal, minimize fuel consumption, and maximize on-time arrivals.
Okay.
You put the AI in a highly detailed simulation of global weather patterns, air traffic, and airport gate availability. The AI tries a routing strategy. If a simulated flight is late or burns too much fuel, it gets punished.
They get scolded.
Right. But if it routes a plane perfectly around a storm system, saving fuel, it gets rewarded. It runs this simulation millions of times overnight, and by morning, it has developed a routing strategy far more efficient than any human air traffic controller could ever design.
Wow, okay, I fully understand the algorithms now. We have these brilliantly designed neural networks, and they are learning through supervision, unsupervised clustering, or reinforcement.
Right.
But all of those algorithms are completely useless if they don't have anything to chew on. Right? A brain can't think in a vacuum. Which brings us to element 2, data.
The fuel.
The fuel for the engine. I feel like I've heard the phrase data is the new oil like a million times at tech conferences. But AI seems to take that cliche to an absolute extreme.
It really does. AI algorithms, particularly deep learning neural networks, are starving for information.
Yeah.
They are gluttons.
Right.
The sudden exponential leaps we've seen in AI capabilities recently are directly tied to the exponential rise in the sheer quantity, availability, and diversity of global data. The tech industry refers to this phenomenon as big data.
Big data. And the report explicitly defines big data using the 4 Vs. Let's break those down because they really explain why data has become so overwhelming for businesses. Volume, velocity, variety, and veracity.
Let's take volume first. The sheer scale of data generated globally is staggering. Every single click, every swipe, every credit card transaction, every GPS ping from a smartphone.
It adds up fast.
We're no longer talking about gigabytes or terabytes. We are talking about zettabytes of data generated annually.
And velocity is the speed at which that data is being created. It's not just a big historical archive sitting in a basement. It's a fire hose streaming in real time.
Exactly. A modern airline isn't just looking at booking data from last month. They are processing thousands of sensor readings per second from the jet engines of aircraft currently in flight, adjusting maintenance schedules in real time. That is velocity.
That's wild. The third V is variety, and I think this is where things change drastically because data used to just mean structured spreadsheets, right? Rows and columns, financial records, passenger manifests.
Yes, that is structured data. It's very easy for a standard computer to read, but the vast majority of data generated today, and the data that AI absolutely loves, is unstructured. That's variety.
Unstructured meaning what?
It's text in an email, it's a recorded voicemail to a customer service desk, it's a video uploaded to TikTok, it's a panoramic photo of a resort. Before deep learning, computers couldn't do much with an unstructured video file. Now they can analyze every single frame.
And the final V is veracity, which means accuracy or truthfulness. And honestly, this seems like the biggest nightmare. If you are scraping the internet for data to train your AI, how do you know the data isn't just garbage?
Veracity is the most complex challenge in the data pipeline. Ensuring the quality, reliability, and lack of bias in data when it is flooding in from billions of diverse, unvetted sources is incredibly difficult.
I can imagine.
If you train a hotel pricing algorithm on historical data that is filled with errors or anomalies, say a massive price drop that happened because of a system glitch, not a real market trend, the AI will learn the wrong lessons. Garbage in, garbage out.
Right. So if a travel company has this massive volume, velocity, and variety of data, where on earth do they put it physically? You can't just store zettabytes of video files on a hard drive under a desk.
No, definitely not. To handle this, we've seen a massive global build-out of physical infrastructure. We're talking about hyperscale data centers.
Those massive buildings.
Huge warehouse-sized facilities filled with thousands of servers. The WTTC report notes a pretty striking geographic concentration here. In 2023, the United States hosted 10 times more data centers than any other country in the world.
10 times. Wow. And when a company stores their data in the cloud, the report talks about the architecture of that storage. They mention data warehouses and data lakes, and then they combine them into something called a data lakehouse.
Yeah.
I have to admit, when I first read data lakehouse, I laughed out loud. It sounds like a tech billionaire's vacation property in Tahoe. What does that actually mean?
It is a bit of a funny term, I'll give you that. But the engineering behind it is critical. Historically, a company used a data warehouse to store its structured data, the neat, organized spreadsheets of financial transactions. It was highly organized, but inflexible.
Okay, that makes sense.
Then came the data lake. This is exactly what it sounds like. A massive, sprawling, unorganized digital reservoir where a company dumps all of its unstructured data, the raw videos, the audio files, the text documents. You just dump it in the lake and worry about organizing it later.
But I imagine trying to find a specific piece of information in a data lake is a nightmare.
Oh, it is. It can turn into a data swamp very quickly. So the data lake house was invented as the modern solution. It takes the vast, cheap storage capacity and flexibility of the data lake, so you can hold all those raw videos and texts, and overlays it with the strict management, searchability, and structure of the data warehouse.
Oh, I see.
It allows a company's AI algorithms to seamlessly query both structured booking data and unstructured customer reviews simultaneously.
That makes perfect sense. So let's tie this directly back to the listener. Let's say you are the CEO of a major cruise line. You have your massive data lakehouse filled with passenger data, weather patterns, food consumption logs, and social media mentions. How does the AI actually use this fuel to help your business? The report lists several specific mechanisms.
When you feed that massive travel data engine into AI algorithms, it unlocks several distinct capabilities. First is feature extraction.
Feature extraction.
This is the ability of the AI to automatically pull highly specific insights out of messy, unstructured data. For example, the AI can read 50,000 unstructured TripAdvisor reviews of your cruise line, extract the specific sentiments, and tell you your guests love the evening entertainment. But there is a statistically significant frustration with the wait times at the breakfast buffet on deck 4.
Wow. Because no human has time to read 50,000 reviews and tally that up.
Exactly. The second capability listed is personalization. And travel is obsessed with personalization right now.
Because it drives revenue.
Completely. By continuously analyzing a customer's past behavior, search history, and interactions across your platform, the AI can offer hyper-tailored suggestions. If the AI knows from the data lake that a specific family books connecting rooms, prefers early dinners, and always purchases snorkeling excursions, the AI can dynamically generate a marketing email offering exactly that package at the exact moment they are likely to book.
The report also mentions natural language processing, or NLP.
Yes, NLP is what allows machines to understand and generate human language. This is what powers the highly sophisticated chatbots that can now handle complex, multi-turn customer service conversations.
Like rescheduling flights or processing refunds?
Right, or answering luggage policies without ever needing to escalate to a human agent, saving millions in operational costs.
And the final one is real-time decision-making.
This relies heavily on the velocity of data we talked about. An AI can analyze thousands of simultaneous credit card transactions across your global booking platform in milliseconds, comparing them against known fraud patterns. If it detects an anomaly, it can block the transaction in real time before the fraud is committed.
Okay, I am fully tracking. We have the brilliant algorithms, the brains, we have the massive data lake houses, the fuel. But to actually process that fuel through the brain, you need raw physical horsepower, you need an engine.
That's a third piece.
Right, element three, compute, the machines themselves.
And this is where the sheer scale of the modern technology becomes almost physically hard to wrap your head around. The computational demands of modern AI are astronomical.
To give the listener a sense of the scale, let me share a statistic from the WTTC report that genuinely made me stop reading and just stare at the wall for a minute.
It's a crazy stat.
It is. In 2022, there were roughly 5.75 billion individual web pages on the internet. If a human being sat down and spent just one single minute reading every single web page, and they never took a break to sleep or eat or use the bathroom, it would take that human being 11,000 years to read the internet.
11,000 years. It's a span of time longer than recorded human civilization.
Yes, but a modern supercomputer infrastructure can ingest, process, and train deep learning algorithms on that exact same vast ocean of data in just a few months. That is what we mean when we use the word compute.
And that level of raw processing power is a relatively new phenomenon. To understand why we suddenly have this power, we have to look at the hardware evolution. For a long time, the growth of computing power was defined by Moore's law.
Gordon Moore, one of the co-founders of Intel.
Correct. Back in the 1960s, Moore observed that the number of transistors you could fit on a computer chip was doubling roughly every 2 years. This meant that computers were consistently getting exponentially smaller, cheaper, and more powerful.
Right.
This law held true for decades and drove the digital revolution.
But the report points out that even the exponential growth of Moore's law wasn't enough to power the deep learning neural networks we just talked about. Standard computer chips hit a wall.
They did.
We needed a totally different architecture. And we got it through a massive lucky accident from the video game industry.
It is one of the greatest ironies in tech history. For decades, standard computers were powered by CPU central processing units. A CPU is a brilliant, highly versatile chip, but it is designed to process tasks sequentially. It executes one command, then the next command, then the next. Very fast, but one at a time.
So if a CPU is a vehicle, it's a Formula One race car. It is incredibly fast, but it can only make one delivery at a time.
That's a great analogy. But in the late 90s and early 2000s, the video game industry hit a problem. They wanted to create highly realistic 3D graphics on computer screens.
Like explosions and lighting.
Right. To render an explosion in a video game, the computer has to simultaneously calculate the lighting, shadows, and trajectory of thousands of individual pixels on the screen 60 times a second. The CPU couldn't do that sequentially. It would lag.
Okay.
So hardware companies invented the GPU, the graphics processing unit. Unlike a CPU, a GPU isn't designed to be one fast race car.
Huh.
It is designed to process thousands of simpler mathematical tasks in parallel at the exact same time.
So a GPU isn't a race car, it's a massive fleet of 10,000 delivery trucks. None of them are as fast as the race car, but they can all take different routes and deliver a massive sprawling payload instantly.
Exactly. And it turned out by pure coincidence that the accelerated parallel processing required to render a video game explosion is the exact physical hardware architecture needed to push data through the complex layers of a deep learning neural network. To train an AI, You have to do millions of simple matrix multiplications simultaneously. GPUs were the missing puzzle piece. When researchers figured out they could hijack video game GPUs to run AI algorithms, the entire field exploded.
That is fascinating. So teenagers playing video games basically funded the hardware revolution for AI.
Basically, yeah.
So there's our foundational formula. The sudden revolution we are living through right now is simply deep learning algorithms fueled by big data running on parallel processing GPUs. Algorithms plus data plus compute.
Now that we understand the raw ingredients inside the black box, we have to look at the final product that comes out. We need to categorize what kind of intelligence we've actually built.
Which brings us to the next section of our deep dive blueprint classifying intelligence, because this is where the hype gets really dangerous.
Oh, definitely.
The media, and frankly a lot of tech CEOs, often talk about AI as if it's this single monolithic conscious sci-fi entity, like the Terminator or HAL 9000. But the WTTC report is very careful to classify AI in distinct ways. Let's start with capability. What is the actual scope of the intelligence we are dealing with?
The scientific community generally breaks AI capability down into 3 distinct levels. The first level is artificial narrow intelligence, or ANI.
ANI.
This is also commonly referred to as weak AI, and this is the most important level for our listeners to understand, because this is where humanity currently lives. 100% of the AI systems in existence today, including ChatGPT, Midjourney, Watson, are narrow AI.
Narrow AI is defined as a system designed to perform one specific task or a very narrowly defined set of tasks,
Yes,
right?
it operates entirely within a predefined context.
So the email spam filter that keeps my inbox clean is narrow AI. The algorithm that recommends what movie I should watch next on Netflix is narrow AI. The computer vision system driving a Tesla down the highway is narrow AI.
Precisely. And they are not interchangeable. The AI driving the car is executing millions of calculations a second, but if you ask it to filter your spam emails, it cannot do it.
Right.
A medical imaging AI trained to detect lung cancer cannot sit down and play a game of chess against Deep Blue. It is incredibly superhumanly good at its specific domain, but it has zero capability and zero understanding outside of that domain.
I have to admit, calling it narrow or weak AI sounds a bit disappointing. Like, is a basic smart speaker telling me the weather really the exact same species of technology as a self-driving car? Are we underselling how powerful this is?
It's a very fair critique. Weak is a terrible branding term. But it's vital to remember that narrow refers exclusively to the scope of the task, not the complexity of the math or the profound impact of the result.
Oh, I see.
Think back to AlphaFold, the Google DeepMind project. That system uses deep learning to predict the 3D folding structures of nearly every single protein known to science. It is solving biological mysteries that humans have struggled with for half a century, accelerating the development of life-saving treatments for diseases like Alzheimer's.
That's huge.
It is. But AlphaFold is narrow AI. It only does one thing. It folds proteins. It cannot tell a joke or order a pizza. But that one single narrow task is fundamentally changing the trajectory of human medicine.
Okay, that completely reframes it. Narrow AI is wildly powerful within its lane. So if we are currently living in the era of narrow AI, what is the next level? What are the tech companies actually trying to build?
The next theoretical level is artificial general intelligence, or AGI. This is also called strong AI. This is the holy grail of the tech industry.
What makes it AGI?
AGI would be an AI system capable of performing any cognitive intellectual task that a human being can do. It wouldn't be confined to a domain. It could learn to play chess and then decide it wants to learn how to write a beautiful poem in French and then apply that creative thinking to figure out a new way to optimize global supply chains.
It has generalized reasoning capabilities. Now, I know you said 100% of current AI is narrow, but I've read headlines where researchers claim they are seeing signs of AGI in the newest models. Is AGI here yet?
The consensus is firmly no. True AGI does not exist yet. You are referencing a controversial paper published by researchers at Microsoft where they claimed they saw sparks of AGI in early versions of GPT-4 simply because the model could reason across so many varied topics seamlessly.
But it's still just text.
Exactly. Many experts point out a massive missing piece for true AGI, and that is embodiment.
Embodiment. You mean a physical body?
Yes. Human intelligence isn't just a brain in a jar processing text. We interact with the physical world. We understand gravity, spatial dynamics, physical cause and effect. If an AGI is supposed to perform any human task, it needs to be able to navigate the real world.
Okay, let's put that in a hotel setting.
Sure. You might have an incredibly advanced robot concierge that can roll across the lobby, pick up a guest's luggage, recognize their face, and carry the bags to room 402. That is amazing robotics and computer vision.
Very cool.
But if that same robot cannot sit down at a desk, analyze the hotel's quarterly P&L statements, and devise a new corporate marketing strategy, it is still just a highly advanced collection of narrow AI systems strapped into a metal chassis. It is not AGI.
Okay, that distinction makes perfect sense. So AGI is the future goal. Is there a level beyond AGI?
The third and final level is artificial superintelligence, or ASI. This is purely theoretical and honestly borders on philosophy. ASI represents a hypothetical point in time, often referred to by futurists as the singularity.
The singularity. That sounds ominous.
It's the moment where an AGI becomes so smart that it can rewrite its own code, iteratively improving its own intelligence at an exponential rate. Within days or hours, it reaches an intelligence that vastly, incomprehensibly surpasses human cognitive capabilities in every single way.
So creativity, scientific wisdom, social skills.
Everything. It raises massive existential questions about humanity's future role, but it is strictly speculative right now.
Okay, so bringing us back down to earth and specifically back to the business of travel and tourism. We've classified AI by capability. We are squarely in the realm of narrow AI, but the WTTC report also classifies AI by functionality. How are businesses actually using these narrow systems today?
Historically, before the events of 2023, business AI functionality fell into two main buckets, expert systems and predictive AI. Let's look at expert systems first. An expert system is designed to simulate the decision-making ability of a human expert in a highly specific field. It is built using two components: a knowledge base, which is a massive database of rules, facts, and domain expertise, and an inference engine, which is the AI brain that reasons through the problem using the knowledge base.
Give me a concrete travel example of an expert system in action. I want to see how the inference engine actually works.
Imagine a massive global tour operator. They want to digitize the brains of their best human travel agents, so they build a knowledge base. They feed it the operational schedules of every train in Europe, the pricing of 10,000 hotels, real-time visa requirements, and the nuanced reviews of thousands of local tour guides.
That's a lot of knowledge.
It is. Then a user logs onto the website and chats with the interface. The user says, I have $4,000. I want to spend 10 days in Italy in September. I hate crowds. I love modern art, and I have a severe peanut allergy.
That's a very specific request.
Right. The inference engine takes that query and logically navigates the knowledge base. It filters out high-season tourist traps, finds niche modern art galleries in secondary cities, cross-references restaurant menus for allergen safety, and outputs a highly personalized, logically sound travel itinerary that rivals what a 20-year veteran travel agent could produce. And it does it in 3 seconds.
That is incredible. It's essentially capturing human domain expertise and scaling it infinitely.
Okay, and what about predictive AI?
Predictive AI is exactly what it sounds like. It uses machine learning algorithms to analyze massive amounts of historical data to forecast future outcomes. It shifts a business from looking in the rearview mirror asking what happened to looking through the windshield asking what will happen.
And this is the absolute lifeblood of modern travel businesses.
Completely. Airlines use predictive AI for dynamic pricing. The AI constantly analyzes historical booking curves, upcoming competitor pricing, and even weather forecasts to adjust the price of a seat on a flight from New York to London minute by minute to maximize revenue.
And hotels do the same thing. Right, for demand forecasting. An AI analyzes historical occupancy rates, local event schedules, and macroeconomic indicators to predict exactly how many rooms will be booked on the third weekend of October, allowing a general manager to optimize staff scheduling, order the exact right amount of food for the restaurants, and manage room inventory dynamically.
Okay, so expert systems and predictive AI are really powerful, but they've been working quietly behind the scenes in corporate dashboards for years. They are mostly analytical. Which brings us to the most exciting and honestly disruptive part of our journey today.
The big shift.
Because if predictive algorithms have been optimizing hotel rates since 2015, why did the entire world lose its collective mind in late 2022? Enter the earthquake generative AI.
Generative AI, or Gen AI, is the spark that ignited the suddenly phase.
Yeah.
This is what tipped the entire AI industry out of the IT department and into the mainstream public consciousness.
Right.
Generative AI is a type of system that doesn't just analyze data, cluster photos, or predict trends. It creates. It produces completely new, original, high-quality content. Text, computer code, photorealistic images, cinematic video, and human-sounding audio.
And the specific match that lit the powder keg was a product launch in November 2022. OpenAI, an artificial intelligence research lab, released a web application called ChatGPT.
Yep.
The adoption rate was something we have never seen before in the history of technology. ChatGPT hit 1 million users in 5 days. It registered 100 million active users in just 2 months.
It's unheard of.
At the time, it shattered the record for the fastest growing consumer application in human history, leaving apps like TikTok and Instagram in the dust.
It was a true watershed moment. And to understand why ChatGPT was so astonishingly capable of conversing like a human, we have to look at the underlying mathematical architecture that made it possible. The origins of Gen AI actually trace back to a massive breakthrough in 2017. A team of researchers at Google published a highly influential paper.
And it has arguably the greatest title of any academic research paper ever. Attention is all you need.
It is a legendary title. That paper introduced a revolutionary new type of deep learning neural network architecture called transformers.
Transformers. Okay, how do they work?
Before transformers, if an AI tried to read a paragraph of text, it had to read it sequentially, word by word, from left to right. By the time it got to the end of a long sentence, it would often forget the context of the beginning of the sentence. It struggled with nuance and long-form language.
So how did the transformer architecture fix that? What does attention mean in a mathematical sense?
Transformers introduced a mechanism called self-attention. Instead of reading left to right, a transformer neural network ingests the entire sequence of text simultaneously. It processes everything in parallel.
Because of the GPUs?
Exactly. The self-attention mechanism allows the AI to mathematically weigh the importance of every single word in a sentence relative to every other word instantly.
Give me an example of how that changes the AI's understanding.
Think about the word bank. If I say, I sat by the riverbank versus I deposited money in the bank, the word is identical. A primitive AI gets confused, but a transformer looks at the entire sentence simultaneously. In the first sentence, its self-attention mechanism draws a strong mathematical connection between bank and river. It instantly grasps the semantic context.
Oh, that makes so much sense.
Because it can understand context over massive blocks of text, it can not only read with incredible comprehension, but it can generate fluid, contextually perfect human language.
And the financial and cultural impact of that breakthrough has been staggering. Just looking at the data compiled in the WTTC report, it paints a picture of a total gold rush. Venture capital investment poured into generative AI startups, reaching over $12 billion in just the first half of 2023 alone.
The money was just flowing.
Global news coverage of the topic skyrocketed. In late 2022, there were maybe 2,000 articles written about Gen AI globally. By June 2023, that number had exploded to nearly 14,000 articles a month. The volume of tweets discussing it jumped from 7,000 to 57,000 in a matter of months.
It completely dominated the global conversation, from boardrooms to dinner tables. Now, because the hype was so massive, a lot of terminology started getting thrown around interchangeably in the business press. If you are a travel leader looking to invest in this, you need to understand the difference between two key terms: large language models and foundation models.
Yes, let's untangle those. What exactly is a large language model, or LLM?
An LLM is a specific application of the transformer architecture we just talked about. It is a massive neural network trained exclusively on colossal data sets of text and computer code.
Just text and code.
Right. Its entire purpose is to understand grammar, semantics, logic, and language patterns. When you talk to ChatGPT, you're interfacing with a large language model. It generates text.
Okay, so LLMs are for text. What are foundation models?
Foundation models, which the European Union regulatory bodies often refer to as general-purpose AI, are a much broader category. They include LLMs, but they're not limited to text. A foundation model is trained on a massive, diverse combination of text, images, audio, and video.
So it's multimodal.
Yes. It acts as a massive general base of knowledge and understanding about the world. And the beauty of a foundation model for the business world is that you don't have to spend $100 million building your own neural network from scratch.
Right. A hotel chain isn't going to build a supercomputer.
Exactly. You license a pre-built foundation model from a company like OpenAI, Google, or Anthropic. Then you undergo a process called fine-tuning.
Fine-tuning.
You take this incredibly smart base model and you feed it your own specific proprietary company data,
Mm.
your brand voice guidelines, your specific cancellation policies, your internal training manuals. The model adapts its vast general intelligence to become a highly specialized expert in your specific business.
Which brings us to what I consider the most magical and honestly most disruptive part of this whole Gen AI earthquake, the new user interface.
Yes, this is huge.
Because for the entire history of computing, if you wanted a machine to do a complex task, you had to speak its language. You had to learn to write code Python, Java, C++. There was a massive technical barrier to entry. But with Gen AI, the new user interface is just natural language processing. The prompt is the new UI. You just type or speak in plain English.
You no longer need to know how to code to command a supercomputer.
Mhm.
You just need to know how to talk. It completely democratizes access to computation.
The WTTC report gives a brilliant, concrete example of what this looks like in practice for a business professional. Imagine you are sitting at your desk, you open a Gen AI interface, you give it a text prompt, asking it to translate 3 distinct, complex paragraphs of text into Spanish, Japanese, and Icelandic. You ask it to do this simultaneously. In less than 5 seconds, it produces perfect, nuanced translations that account for local idioms. Or, in another example from the report, you prompt the AI to create a comprehensive summary table of all the major reports published by the WTTC in the year 2022, and you ask it to include a 1-sentence description of each report in the second column. It appears instantly.
And here is the absolutely crucial distinction that people must understand. When you asked it for that table, the AI did not just execute a Google search, find an existing table on the WTTC website, and copy-paste it into your screen. That table did not exist anywhere on the internet in that specific format.
It created it.
The AI generated it fresh, word by word, by statistically predicting the next logical word based on its vast training data. It synthesized disparate pieces of information on the fly to fulfill your unique command.
This is where we have to slam on the brakes and talk about the danger. Because that exact example from the WTTC report, the one where they asked the AI to build a table of 2022 reports, it failed. The AI made a significant mistake. It missed 2 major reports that were published, that year 1 report on hotel investment and another report on the circular economy. It didn't warn the user. It didn't say, I think I might be missing some. It just confidently left them out and presented the table as absolute fact.
Yes, and this highlights the fundamental, glaring flaw of generative AI in its current state. It lies. Or, to use the formal industry term, it hallucinates.
I find the term hallucination so fascinating. Why does a supercomputer that has read the entire internet hallucinate? It's not on drugs. Why does it lie?
It's not lying with malicious intent. It's a byproduct of how it predicts text. The WTTC report lists 4 primary reasons why an AI system hallucinates. First, the model might not have been trained on enough diverse data to fully grasp the specific topic you are asking about, so it guesses.
Okay, that makes sense.
Second, it might have been trained on noisy or dirty data. If the internet contains conflicting information or widespread myths about a topic, the AI internalizes those myths as facts. Third, the user might not have given the AI enough context in the prompt, forcing the AI to make unwarranted assumptions about what you want.
And the fourth,
The model may lack sufficient internal constraints. It hasn't been properly programmed with the boundary condition to admit ignorance. It doesn't know how to say, I don't know.
I love thinking about generative AI through an analogy here. I call it the people-pleasing intern syndrome.
I love that.
Imagine you hire a new intern for your travel agency. This intern is technically brilliant. They have literally memorized every book in the library. They speak 50 languages fluently, and they can type 1,000 words a minute. They are a prodigy. But they have a deep psychological flaw. They are absolutely desperate to please you. They want your approval more than anything.
So they guess.
Right. You ask the intern a question, hey, what are the visa requirements for a Canadian entering Vietnam this month? The intern searches their brain. Maybe the policy changed recently and they don't know the exact answer, but they're so terrified of disappointing you by saying, I don't know, that they confidently invent a highly plausible sounding, official looking lie and hand it to you with a smile.
That is a highly accurate way for a business leader to view this technology. You are managing a brilliant but occasionally delusional entity. You must always verify the intern's work.
Right. Because the stakes in business are real. If you deploy a custom AI chatbot on your airline's website to handle customer service, and a customer asks about baggage fees, and your AI confidently hallucinates a policy saying all surfboards fly for free, Your business is legally on the hook for that hallucination.
Exactly. The deployment of this technology requires rigorous human oversight, guardrails, and continuous testing to mitigate those risks. You can't just set it and forget it.
Which perfectly transitions us into the final major section of our deep dive AI in the wild. We've explored the history, we've opened the black box of algorithms, data, and compute, we've seen the earthquake of generative capabilities. So what actually happens when this incredibly powerful, highly accessible, occasionally hallucinating technology collides head-on with human society and the broader global economy?
The societal impact is profound, and it is moving faster than regulators can keep up. The WTTC report points out several significant dilemmas, but it starts by highlighting the massive implications of visual generative AI and the rise of the deepfake.
We have to talk about the disinformation examples mentioned in the text because 2023 was truly the year seeing stopped being believing. Highly convincing, photorealistic fake images went completely viral globally. Millions of people scrolled through their social media feeds and saw an image of the Pope striding through a crowd wearing this incredibly stylish, oversized white Balenciaga puffer jacket.
I remember seeing that.
It looked like a high-fashion paparazzi shot. And around the same time, millions more saw images purporting to show the dramatic, physical arrest of former U.S. President Donald Trump, with police officers grabbing him.
Right.
Now, keeping this strictly focused on the technology itself, the terrifying thing wasn't just that these images were fake. We've had Photoshop for decades. The paradigm shift was that these images were generated by everyday people sitting at home, typing a simple text prompt into a program like Midjourney. It took them seconds. And the output was so flawless in its lighting, texture, and realism that it bypassed the critical thinking filters of a massive portion of the global public.
It's a profound challenge to digital literacy. It demonstrates that the wide-scale implementation of AI is going to require serious technological guardrails, like digital watermarking on AI content, so society can verify what is synthetic and what is reality.
But, as the report importantly points out, deepfakes and synthetic media aren't solely tools for disinformation. There is massive, legitimate commercial value here if the technology is used ethically, transparently, and with the consent of the subject. And the primary example the report gives is absolutely brilliant. Let's look at the Lionel Messi campaign for PepsiCo.
Oh, the messymessages.com campaign. This is a masterclass in the commercial application of Gen AI.
Break down how this worked, because it wasn't just a regular TV commercial.
No, it was highly interactive. PepsiCo partnered with a tech firm to create an authorized, high-fidelity AI digital clone of the global football superstar, Lionel Messi. Fans could go to a dedicated website and interact with the AI. The fan would type in their own name, the name of a friend, and a few details.
Okay.
The AI would then generate a hyper-personalized custom video of Lionel Messi. The video would show Messi looking directly into the camera, addressing the fan's friend by their specific name, inviting them to come over, grab some snacks, and watch a UEFA Champions League football game.
That is so cool.
And the kicker. The AI could generate Messi speaking flawlessly in English, Spanish, Portuguese, or Turkish, matching his lip movements perfectly to the generated audio in real time.
It's mind-blowing, and I want the travel and tourism leaders listening right now to extrapolate that out. Think about the application for your industry.
The possibilities are endless.
Imagine hyper-personalized marketing at an infinite scale. A tourism board in Japan could license the digital likeness of a famous local ambassador. A prospective traveler in Brazil is browsing the tourism website. The AI instantly generates a custom video of that ambassador standing in front of Mount Fuji, speaking fluent Portuguese, addressing the traveler by name, and suggesting a bespoke 5-day itinerary based entirely on that user's past browsing history of culinary tours.
The marketing conversion rates on that level of personalization would be astronomical.
The potential for customized guest engagement is limitless, but as this technology inevitably rolls out across the corporate world, we also have to confront the most pressing societal friction point, the impact on human labor.
You cannot talk about AI without talking about jobs. And the 2023 Hollywood writers and actors strike serves as the prime example in the text.
Yeah, that was a huge moment.
The entertainment industry effectively became the canary in the coal mine for the AI labor revolution. For months, film and television production ground to a halt. And while compensation was a major issue, the core of the strike was fundamentally about existential technological threats.
What were they specifically worried about?
Writers were striking because they were terrified studios would use LLMs to generate rough drafts of scripts and then just hire human writers at a fraction of the cost to punch them up. Actors were striking because they feared studios would require them to step into a scanning booth, capture their physical likeness and voice, and create an AI digital replica.
Wow.
The studio could then use that digital clone in background scenes in perpetuity, forever, without ever needing the actor's physical presence on set again and without paying them a daily rate.
And some actors were even raising alarms about studios owning the rights to use their digital likeness long after they had passed away. It sounds dystopian, but the technology is already here to do it. And the report notes that this isn't just a Hollywood problem, it is a bellwether.
Exactly.
As AI becomes more capable of answering customer service calls, writing marketing copy, analyzing financial data, and managing logistics, labor strikes, and union negotiations over AI protections are highly likely to spread to other sectors. Which brings me to a critical thought for our listener.
This is the big takeaway.
You are a leader in travel and tourism. We have just spent an hour doing a deep dive into how AI can optimize your flight routes, dynamically adjust your hotel room pricing, extract sentiment from 50,000 reviews, build personalized itineraries in 3 seconds, and act as a 247 virtual concierge in 50 languages. You could look at all of that and think the goal is to automate your entire business. But at its core, travel is not a digital product. It is fundamentally, intrinsically a human experience.
And that is the ultimate takeaway of the entire WTTC report. We circle all the way back to Julia Simpson's foreword. She makes a very grounding, philosophical statement that every tech-obsessed CEO needs to hear. She says, ultimately, AI is just an engine.
An engine.
An engine is powerful, but an engine does not decide where the car goes. The goal of implementing AI isn't to replace the human experience of travel. The task for leaders is to ensure this powerful new engine fuels us toward a destination of our own choosing, a global travel sector that is greener, safer, more prosperous, and more accessible.
AI handles the data, humans handle the hospitality, human oversight, genuine empathy, the warmth of a smile at a front desk, the unscripted creativity of a local tour guide. Those human elements will be what actually delivers meaningful, memorable travel experiences that keep guests coming back. The AI just clears the administrative brush out of the way so the humans can do what they do best.
Precisely. It is about augmentation, not replacement.
So let's take a breath and recap the monumental journey we've been on today. We started in 1950 with Alan Turing, asking the theoretical question of whether a machine could think. We watched the technology build gradually for decades, climaxing with massive supercomputers doing complex math to beat humans at chess and trivia.
It was a long build-up.
Then we explored the sudden, explosive shift into creative capabilities. We opened the black box and found the convergence of highly sophisticated deep learning algorithms, oceans of unstructured big data stored in massive lakehouses, and the raw parallel processing power of gaming GPUs.
The trifecta.
We clarified that while we are absolutely still living in the era of narrow AI, the introduction of transformers and foundation models has given us generative AI acting essentially as a hyper-personalized, eager-to-please, occasionally hallucinating intern capable of transforming how every facet of a travel business operates.
It is an immense amount of information to digest. But taking the time to understand these underlying mechanics, separating the genuine technological breakthroughs from the marketing hype, is exactly what gives a business leader the power to leverage AI as a tool rather than being disrupted by it as a threat.
Absolutely. Knowledge is the only insulation against disruption. And I want to leave you, our listener, with a final, provocative thought to mull over as you go back to running your business, something that builds on everything we've unpacked today.
Let's hear it.
Think all the way back to the original Turing test from 1950. The entire premise of Alan Turing's imitation game was a machine's ability to fool a human into thinking it was real. The goal was to trick us. But as a leader in the travel and tourism industry, your goal in the coming decade is not to trick your guests into thinking a chatbot is a human being. Your goal isn't a flawless deception. The real test for your business is the exact opposite.
To every point.
How can you use the immense, invisible, parallel computing power of AI to completely strip away the friction of travel? How can you automate the stressful logistics, the dynamic pricing, the complex scheduling, and the endless data crunching constantly running behind the scenes? Because if you can hand all of that invisible friction over to the machine, then the actual human-to-human interactions your guests have with your concierges, your flight attendants, your local guides, your staff can be more present, more authentic, and more deeply meaningful than ever before.
If you get that balance right, if you let the machines be machines so the humans can be more human, the destination for your business will be very bright indeed.
Thank you so much for joining us on this deep dive. Keep exploring, keep questioning the technology, and keep learning as this sudden revolution continues to unfold. We will see you next time.